Hello student, welcome to your chemistry lab. Today I am discussing chemical bonding. Here I will be discussing fifth part of chemical bonding, that is bond length, bond angle, bond energy of covalent bond and also dipole moment. It is important for JEE and NEET and also for board. So read very carefully. So now watching the whiteboard. Important characteristic of covalent bonds. Covalent bonds are characterized by some parameter which are follows. First point, bond length. The average distance between the center of the nuclei of the two bonded atom in a molecule is known as bond length. It depends upon the size of atom, hybridization, steric effect, resonance, etc. Usually, bond length of polar is smaller as compared to a non-polar bond. Bond length increases as the size of atom or orbital increases. Important features of bond length. First point, bond length of the homonuclear diatomic molecules are twice the covalent radii. Bond length increase with the increase of the size of atoms. H2 is 0.74 Armstrong, CH 1.09 Armstrong and CCl 1.77 Armstrong. Point 2. The length of double bond are less than the length of single bond between the same atom, and triple bond are even shorter than double bond, means single bond, double bond and triple bond. Point 3. Bond length decreases with increase in s character, since s orbital is smaller than p orbital. In CH4 means in alkane, CH bond is 1.112 Armstrong because here carbon atom is sp3 hybridized, that is 25% s character. In alkene, CH bond equals to 1.103 Armstrong because here carbon is sp2 hybridized, means 33.33% s character. In alkyne, CH bond is 1.08 Armstrong and here carbon is sp hybridized, means 50% s character. Point 4. Bond length of a polar bond is smaller than the theoretical non-polar bond length. Point 5. Bond length is affected by resonance and hyperconjugation. Bond enthalpy. Bond enthalpy is the amount of energy required to break a particular bond in 1 mole of gaseous molecule. Bond enthalpy directly proportional to electronegativity, inversely proportional to size of atom and inversely proportional to number of lone pairs of electron. Important features of bond energy or bond enthalpy. First point, the magnitude of the bond energy depends on the types of bonding. Most of the covalent bond have energy between 50 to 100 kilocalorie per mole, that is 200 to 400 kilojoule per mole. Strength of the sigma bond is more than that of Y bond. Point 2. Double bond in a diatomic molecules has a higher bond energy than single bond, and triple bond has a higher bond energy than the double bond between the same atom, that is the CC triple bond energy is more than CC double bond than CC single bond. Point 3. The magnitude of bond energy depends on the size of atom forming the bond, that is the bond length. Shorter bond length, higher is the bond energy. Point 4. Resonance in the molecules affect the bond energy. Point 5. The bond energy decreases with increase in number of lone pairs on the bonded atom. This is due to electrostatic repulsion of lone pair of electron on the two bonded atom. Point 6. Homolytic and heterolytic fission involve different amount of energies. Generally, the value are low for homolytic fusion of the bond in comparison to heterolytic fission. Point 7. Bond energy decreases down the groove in case of similar molecule. Point 7. Bond energy increases in the following order: S, P, Sp, Sp2, Sp3. And here Cc is 346, no lone pair. In Nn means nitrogen, 163, one lone pair. And oxygen, Oo, is 146.4 kJ per mole, two lone pair are present. Point C. Bond order. It is the number of covalent bonds present between the two atoms in a molecule. Bond order directly proportional to bond enthalpy or bond energy and inversely proportional to bond length. D. Bond angle. It is the angle between the bonded orbitals. Presence of the lone pair of electron greatly affect the bond angle. Some example: lone pair repulsion, steric number is 3. Bond angle in NO2 positive, NO2 and NO2 negative are follows. NO2 positive have 180 degree, NO2 have 134 degree and NO2 negative 115 degree. Because the lone pair in NO2 negative exert effect than a lone pair electron in NO2. Thus the bond angle NO2 negative is less than the NO2. NO2 positive ion is linear since it does not have lone pair or one electron. Similarly, in BF3, the calculated bond enthalpy is 150 picometer, but experimental value is 103 picometer. According to the rule 6, if the lone pair on fluorine is donated to boron atom through p-pi bond, the electron density at fluorine decreases, get stabilized, due to which BF bond get a double bond character, lowering the bond length. Steric number 4. The isoelectronic molecules CH4, NH3, H2O and HF, and their structure are presented. And first one is methane, bond angle is 109 degree 28 minute, no lone pair. Second one is ammonia, bond angle is 107, one lone pair present. Water, bond angle 104 degree, two lone pair. And HF, hydrogen fluoride, three lone pair are present. Illustrate the lone pairs on molecular shape. Methane has 4 identical bonds between carbon and each of the hydrogens. When the 4 pair of electrons are arranged as far from each other as possible according to rule number 1, the result is familiar tetrahedral shape and with 6 regular tetrahedral angles, that is 109 degree 5 minutes. Similar tetrahedral arrangement probably occur in covalent compounds of trivalent nitrogen, divalent oxygen and monovalent fluorine. The nitrogen atom in NH3 molecule is surrounded by 3 bond pair and 1 lone pairs. Oxygen in water is surrounded by 2 bond pairs and 2 lone pairs, and fluorine is in hydrogen fluoride is surrounded by 1 bond pair and 3 lone pair. The bond angle in ammonia and water is less than the tetrahedral bond angle due to the Getter repulsion effect of the lone pair as compared with the bond pairs. Also, it can be seen that as the number of lone pairs increases, decrease in bond angle is more, as can be observed from the bond angle of NH3 and H2O. As per rule 3, the bond angle in molecules having steric number 4 decrease with increase in the electronegativity of the bonded atom or decrease in the electronegativity of the central atom. In other words, bond angle decreases with increase the size of bonded atom or decrease in the size of central atom. This is because when electronegativity of bonded atom is more, the bond pair of electron move away from the central atom, thereby contracting and thinning out of the orbital, thus causing decrease the repulsion between bond pairs and coming close to each other. And the example is regard include H2O is 104 degree greater than OF2 103 degree. NH3 is 107 degree greater than NF3 102 degree. Pi3 angle 102 degree greater than PBr3 101 degree greater than PCl3 bond angle 100 degree. The electronegativity order is chlorine is more than bromine than iodine. Similarly, NF3 and NH3 both have structure based on tetrahedron with one corner occupied by a lone pair. First one is NH3 bond angle 107 degree, one lone pair. Second one NF3 bond angle 102 degree, one lone pair. The electronegativity of fluorine pushes the bonded electron further away from nitrogen than in NH3. Hence, the lone pair in NF3 causes a greater distortion from tetrahedral and gives a FNF bond angle is 102 degree as compared with 107 degree in NH3. The same effect is found in H2O bond angle 104 degree and F2O bond angle 102 degree. The bond angle of PF3 greater than PCl3. The PF3 molecule has lone pair of electron on F atom and P has vacant d orbital. The small size of F atom means fluorine atoms lead to p pi d pi bonding in PF3 as shown in figure. The double bond formation increases the bond pair repulsion to result in increased bond angle in PF3. In PCl3, the Cl atom being larger in size does not show p pi d pi bonding. Dipole moment. The polarity of covalent bonds result in the formation of electric dipole causing a permanent dipole moment mu, which is defined as the product of net charge and the distance between the two charged atom or bond length, that is mu equals to E into D equals to charge into distance. The unit of dipole moment in CGS system is dBi and SI system is coulomb meter. Dipole moment is vector quantity and thus indicated by the pointing towards the negative end, as for example HCl. Dipole moment indicate positive to negative. For symmetrical molecules, dipole moment is 0, but unsymmetrical molecules have some dipole moment. For example, carbon dioxide CO2, VF3, CH4, etc. being symmetrical have zero dipole moment. That is, the carbon dioxide dipole moment is zero. Carbon have positively charged, oxygen is negatively charged. Dipole moment indicate positive towards the negative. In BF3 molecules, dipole moment is zero. Boron is positively charged, 3-fluorine is negatively charged. We know that dipole moment indicate positive towards the negative. So above bond means above BF bond is one side dipole moment showing, and two side BF bond is residual is this is, and overall dipole moment in opposite in sign, opposite in direction, so dipole moment is zero. In CH4 molecule, dipole moment is zero because here this structure is tetrahedral and carbon here is negatively charged and hydrogen is positively charged. So dipole moment indicate positive towards the negative. So here 3 CH bond dipole moment, residual dipole moment showing this, and 1 CH bond dipole moment show this, and 2 same direction and opposite side, so dipole moment is zero. However, unsymmetrical molecules like HF, H2O, NH3 have some dipole moment as first one HF. Hydrogen is positive, fluorine is negative, so dipole moment indicate positive towards the negative. So here some dipole moment is present, that is mu equals to mu not equals to 0. In H2O molecules, dipole moment is present because it is tetrahedral structure, 2 lone pair are present and 2 OH bond are present, and here 2 OH bond residual dipole moment this, and 2 lone pair residual dipole moment is this. So overall dipole moment not equals to 0, means mu not equals to 0. In NH3 molecule, here 1 lone pair and tetrahedral structure, and here showing that 3 NH bond at residual dipole moment positive towards the negative this, and 1 lone pair have this, so same direction are showing, so dipole moment, that is mu not equals to 0. By using dipole moment, the percentage of ionic character of a polar bonds AB can be calculated. Percentage of ionic character equals to mu experimental by mu calculated, means experimental value of dipole moment by calculated value of dipole moment into 100, that is equals to mu experimental by DAB into charge, means distance means bond length into charge into 100. Resultant dipole moment may be calculated by using vectorial method. Mu r equals to root over mu 1 square plus mu 2 square plus 2 into mu 1 into mu 2 into cos theta. When theta equals to 0, the resultant is maximum. Mu r equals to mu 1 plus mu 2. When theta equals to 180 degree, the resultant is minimum. Mu r equals to mu 1 minus mu 2. Important conclusion of dipole moment. First point, dipole moment directly proportional to electronegativity difference. For example, HF greater than HCl, HBr greater than HI. Point 2, dipole moment directly proportional to number of lone pair of electrons. For example, HF greater than H2O greater than NH3. Fluorine has 3 lone pair, oxygen have 2 lone pairs, and nitrogen has 1 lone pair. Point 3, dipole moment inversely proportional to theta. For example, ortho greater than meta greater than para. This is the ortho is 60 degree, meta is 120 degree, para is 180 degree. Point 4, homoatomic molecules and molecules having normal shape such as linear, trigonal, tetrahedral possess zero dipole moment. For example, Cl2, N2, O2, CO2, BCl3, CCl4, SiCl4. Point 5. Molecules having distorted shape like angular, pyramidal, seesaw, etc. show dipole moments. For example, H2O, SO2, H2S, NH3, SF4. Point 6. Dipole moment of a cis alkene is more than trans alkene. In trans alkene, it is 0 due to the similar group or symmetry. It should be noted that if the two groups have opposite inductive character, then the trans isomer will have greater dipole moment. I think you are enjoying to watch my video. I think you are understanding all the points. If are not clear, so comment me. I will be replied you. If you are need to discuss any topics, please comment me. I will be discussing for you. So thank you everyone. Bye bye.